Hello everyone. Now I am going to explain problem number 1 of the assignment number 6. So given a string, longest palindromic sequence in a string is you need to find out, or you need to give the length of the longest palindromic sequence. So for example, if BABAD, if it's a string, then longest palindrome is BAB. Palindrome is a string where if you read it from the front or from the back, it reads the same, or from the center it has the same characters on the left and right. So the another example of, or another answer can be ABA as well. So the simple solution is to check if each substring is a palindrome or not. This needs like running the loop 3 times. So it's the time complexity is order of n cube and space is order of 1. More efficient approach means more than this can be that the complexity can be reduced by storing results of sub-problems, and when we store the results of sub-problems and when we go back to access it is backtracking, and that's using the dynamic programming approach. So for this solution I'm going to use the dynamic programming approach. So here we are going to maintain a boolean table of n is the length of the string that is filled in bottom-up manner, or the value of table is true if the substring is a palindrome, otherwise false. To calculate table ij, we first check the value of the tables so that if the center alphabet or the substring at the I plus 1 and j minus 1, if it is a palindrome, then it is if it is true, and if this character at string of I and of j is equal, then we make this table of ij value true, otherwise the value is made false. So this is the code. First I'll explain you how it works. So we'll start with making, so palindrome single length characters are all palindromes, so we make these diagonal indexes, diagonal values true because they all are individually palindromes. Then we will go for the length of 2, where BA is not a palindrome, so false. AN is not a palindrome, so false. NA is not a palindrome, so false. AN is not a palindrome, so false. And NA is not a palindrome, so false. We will set it as a false value. Now we'll go for the length of 3. Again here we will check the conditions to be checked is if the value which is at the, so first we will check if this character and this character matches, and if this is true, like the table of I plus 1 and j minus 1 value, if it is true, and also it has to have this I and the j. So I is going to since k is right now we are considering length as k, or current length of the string, which substring which are considering is 3. So I is equal to I is going to point to the I is going to point to this character, and j is going to point to this character, and that can be calculated by I plus k minus 1, which is I is 0 plus 3 minus 1 will be 2. So B and N will be checked. If since these two are not equal, even though this is true, this will be false. Similarly for these two, this value is, so we will move, and then this value will be true, so this is false, obviously, sorry. So with this, since n is a palindrome here and these two characters match, so this value, which is the current value of table of ij, which is I is 2 and j is 3, that will be true. And then same for this NAN. A is a palindrome and these two characters match, so this is true. And at the same time, when we are going to maintain the maximum length as the whenever we find a palindrome, we will update the maximum length depending on the condition. If maximum length is, so far maximum length is greater than the value of k, then maximum length will remain same. If k is greater, then we will assign k as a k is equal to maximum length is equal to k. So far we have we have found only 3 character substrings which are palindromes in this. So for this also n is a palindrome and these two are same, so this entry is true, or else it is false. So now we will consider the 4-letter strings. So now k is 4, I is pointing here and j is pointing here. So we will check if these two characters match, and if this is a palindrome. So these two characters don't match, so this is not a, entry will be false. Now these two characters don't match, so this entry will be false. Here these two characters don't match, so this entry will be false. Now we'll consider taking 5 so here n is, even though n is a palindrome, center of this, and or the substring here is a palindrome which is a and a, but these two characters don't match, that's why the entry will be false here. And now we will consider taking these. So here a here is a palindrome with these 3 as a substring, so and these two characters match, so this entry will be true. And since now k is greater than max length, so max length will be equal to 5, and at the same time and for 6th one these two characters don't match, so this will not be a palindrome, and max length will be 5 so far. And we are going to keep track of the starting index of the palindrome by storing that string of I in that start variable, and from there to the max length we will get the palindrome, which is the longest palindrome of that substring of that string. Now here time complexity will be order of n square, and auxiliary space required will be order of n square as well to store the values of this table of n by n. N is the length of the string. Now this is the code. So this function is written to return the, if we are passing a string, it will return the longest palindromic substring. So we are declaring this is n is the length of the string, table is declared to store the boolean values, and all the values will be false if the substring is not a palindrome, or else they will be true if the substring of that length will be a palindrome. Now max length is going to keep track of the storing the maximum length of the longest palindrome. So here we are going to check one length. We are going to assign all the table values for the palindromes of length 1 as true for using this for loop. Then in this we are going to check for adjacent values of the palindrome using the where k is equal to 2 or the maximum length is equal to 2, and we are going to, if they are same then we will assign it as true or else false. And we are going to assign start, which is storing the starting index of the longest palindrome, and max length is assigned 2. Now for the checking for the length of the palindromes which are greater than 2 sizes, so k will start from 3 to n is the maximum length, and for I is equal to 0 to n minus k plus 1 and plus I. So j is the character which is at the kth length from the ith character, which is going to be accessed using this, and we are going to check if the substring from the index to jth index, if string of character at I plus 1 and j minus 1 is a palindrome, then only first one condition is that if this the substring should be a palindrome, then only, and the characters at the I and jth position should be equal, then only the value should be assigned true. And then if k is greater than maximum length, then we are going to assign start as I here and max length as k, and this will return. So this will iterate through all the palindromes like n times, and then longest palindromic substring here is at the, so this is the function written to print the substring at these locations. So substring of this string from start to start plus max length minus 1 and return, so this function will return the max length. So if the input is given as, so this is the function to print the substring, and then this is the driver code. And if the input is given as BABAD, so BAB will have a length of 3, or ABA will have a length of 3, or if the input is given as banana, the output will be ANA, or and the length will be 5, which is written. And time complexity of this algorithm is order of n square, and the space complexity is order of n square, where we are storing these table values. And this is the worked out example for this using the dynamic programming approach. There is another one which is Mankar's algorithm, which gives the linear complexity. I'm still studying that. So thank you for watching.